This is a story of a bridge constructed in Buchanan County, Iowa, from start to finish. The first built using a design created with eSpan 140. This project was a collaboration between Buchanan County, the Short Span Steel Bridge Alliance, and its university partners, made possible by the donations of various Short Span Steel Bridge Alliance members.
We were sitting in meetings and discussing it, and when I heard of the opportunity, my answer was, I'm all for it, let's go. Well, basically, this is a bridge replacement on Buchanan County's heaviest traveled county road. And if you would visit with the mayor just up here in Jesup, his answer is he would get nervous virtually every time he crossed the old bridge. It was narrow with a lot of traffic. It was built in the 1930s. It wasn't built for the loads of today. We started out with the design, so I used the eSpan 140 computerized system for doing the design, putting the plans together. And this is something that I'm not real computer literate, but I found it exceptionally easy. We build quite a few bridges ourselves, and what this does, the eSpan 140 gives me another option. So I can start comparing prices and find out what's going to be the most economical answer in each location. And prior to the eSpan 140, I didn't have that tool and wasn't even looking at the steel bridge options.
We took the automated design out of the eSpan 140 and modeled it in our CAD workstations. We export the results of that into our computer controlled machines, and then from there the line processing happens. They come in to approximate length within a few inches, and then they are cut to exact length so that the bearing points are exact to match a survey in the field, and the distance beyond the bearing points are exact so that they can create an expansion joint at either end of the bridge. The intent of cambering the steel is to counteract the deflections from the dead loads imposed on the bridge. So it's simply a way to get your beam to end up being along the grade or slope that you intended. We really recommend hot dip galvanizing. It's a very low maintenance or maintenance-free type of corrosion protection. So it metallurgically bonds to the steel under the conditions in the zinc kettle and protects those beams for over the 50-year design life of the bridge up into 75 years plus.
This is a little bit bigger than we had ever done before. You know, I think it's possible for people to do it if, you know, get enough help and talk to some other people. You know, we pretty much did this on our own. Us using railroad cars and wood timber bridges, we don't get to see the steel structure as much as this. There's a lot of steel went into this. It's well built.
We're instrumenting the bridge at two separate times during the life of the structure. First, we're looking at the construction load effects, principally the lateral flange bending in the exterior girder when we cast the concrete deck. And then at a later time, we'll come back and place more instrumentation on the bridge to look at how does the bridge meet design code criteria, with things such as live load stress ranges, force distribution, and things of that nature.
What we're using is a system called the STS Wi-Fi system, manufactured by Bridge Diagnostics Incorporated out of Boulder, Colorado. It's a really versatile system for field testing of steel girder bridges.
Well, for county engineers, the opportunity to see that this bridge can be put in place very simply and very cost effectively and also have a very safe design allows them to have confidence that eSpan 140 is a tool that they can use in their county to design bridges using steel.
So if you can clear span things, then what that does for you is it eliminates the need to try and build a pier. So where if you can go up to 140-foot spans, that's tremendous. The other thing going on is the steel beams are lighter than the concrete beams. So it doesn't take the heavy equipment. If you're not dealing with some real long leaks, you're probably able to just set them with a hydraulic excavator rather than bringing in a crane.
Well, certainly we want to have products that can meet the needs, both in terms of safety and cost efficiency. But the biggest need in rebuilding America's infrastructure is the financial side. How are we going to pay for it? The Highway Trust Fund is at a point right now where unless we find new ways to bring money in, it's going to run into a deficit situation fairly quickly. So the federal government working with state and counties are going to have to find the money to do this, and what we are doing in the steel industry is making sure when that money is available, we can give them a cost-effective solution.